All right, another section we're going to jump into and dealing with linear situations would be the situation talking about linear inequalities. Inequalities, again, greater than or equals, less than or equals to. So what happens is in the difference between that and an equation. In an equation, we found x equals a given value. There was one value that worked for most of our equations we dealt with. Now there's going to be a whole bunch or an infinite number of solutions that are going to work for it. So for instance here, in this first one, x is less than or equal to 4. I want any values that are less than or equal to 4. So 4 is actually a solution here because of the equals, but so is 0, so is -8, so is -200. Okay? So one of the pieces we're going to start with is looking at the idea of graphing these inequalities. And I keep it pretty simple usually. So what we're going to do is we're going to put these graphs on a number line so we can visually see where these solutions are. Okay, so all I ever ask people to do is step number one is to put a point on their number line, or to put the fewest number of points we have to, and that's the one that we're using comparing to my variable. So here I'm comparing x with 4. Okay. Second thing we have to worry about is open or closed circle. Now open is when we have strictly less than or strictly greater than, and the idea again is that we don't want to include that as our solution. Okay, so if I had, say, x greater than 7, 7's not a solution, so it's almost like a fence, and on that fence, I'll use that example a lot of times, it's not my yard, it's not my neighbor's yard. Okay. We'll use the closed circle when we do have the equal sign to indicate that this is also a solution at 4. Okay. And then we just want to draw an arrow in the direction of where all my solutions are, because like I said, with x is less than 4, 0 is a solution, -2 is a solution, so on and so forth. Now, I know some of us struggle with the idea of which one's less than and which one's greater than. Okay. And what I always tell people is kind of think of the one that looks like an L if we twist it a little bit as your less than. Okay. So less than, the other thing that it does is it points to the left. Okay. And then greater than. So the nice thing is, and we're going to work on get my variable on the left side, because then the inequality points the direction we should go. Okay, so since my inequality is pointing to the left, that means my solutions should point to the left. And I usually have my arrow above the line so it's easier for me to see. Okay, so if I went with my next situation, x is greater than -7. Okay, number line, comparing to -7. No equals, we don't want -7 to be looked at as a solution, so we put an open circle. It's pointing to the right, so we're going to go to the right. Third example, 9. You have the equal sign. Now, here's where we have to be careful. Okay, because this gets people goofed up a lot of times, because if you read it, we read left to right, we say 9 greater than or equal to x, and our brain tells us that we want numbers greater than. Okay, and so we automatically think of numbers like 10 and 11 and so on and so forth, but if I looked at 9 greater than or equal to 10, that's not a true statement. And that's another reason why I always tell people put your variable on the left side. Okay, now my inequality's always got to point the same direction. So if it's pointing at the x in the original, it's got to point in the x in my new one. Okay, so it's actually saying x is less than or equal to 9. Okay, so we've got to be careful. That's the other reason why I want to put my variables on the left side, is so that it makes sense for me when I read it. All right, so when we solve linear inequalities, if you look at these steps, they look pretty similar to what we did with the equations, and they are. Okay, number 1, we get rid of groupings or parentheses. Number 2, we take care of our fractions. Number 3, combine our terms. Number 4, variables on the same side. Then we get to our two-step situation where we add or subtract a constant, multiply or divide my coefficient. Now, that's the place where we have a difference. And that's why I talked about when we do step number 4, getting my variable on the same side, that if I move the smaller, it keeps it positive. Because when I multiply or divide by a negative, Okay. What I need to make sure is to change the direction of my inequality. Now, this first example, I'm dividing by -4. Okay. Because my negatives will go to positive, my 4's go to 1, so I'm left with x. Over there, 16 divided by -4. I switch my sign. Okay. Now, over here, though, I'm dividing by +4. Sometimes people think because there's a negative in there that they have to switch the sign. No, it's what I'm dividing by, and I'm dividing by a positive value. Okay, and so when I do that, my sign does not switch. And then finally, we check, and we should really do 2 points. One of those points is the point that makes it equal. Okay. So for instance, back here on this example, I would want to plug in -4 to make sure those two sides balance. Okay. And then what I like to do is check, because most of the time you'll graph them, is another point, and I like to use 0. Because 0 has some nice properties that when I multiply by 0, that value will go to 0. If I add 0, my number doesn't change. And what you just have to recognize is, okay, when I plug in 0, is it supposed to be part of my solution set or is it not? And so if it is part of my solution set, when I plug it in, it should be a true statement that I get out. Okay, so for instance, going back here to this first example, x is less than -4. 0 is not part of that solution. You can see that by the graph. Okay, so it should not give me a true statement. So when I plug it in here, -4 times 0 is 0. That's not greater than 16. Okay. Whereas over here, x is greater than -4, 0 should work. When I take 4 times 0, 0 is greater than -16. And that's one of the points with inequalities that I'll try almost all the time is 0. All right, so solve and graph. Okay. We solve it just like we do our equations. So number 1, parentheses, groupings, don't have them. Okay, number 2, no fractions, no terms to combine, no variables to get both sides. And this is actually a pretty simple 2-step case. So again, get rid of your constant, do the opposite. Instead of taking a -8, we want a +8 to get that to go to 0. Leaves me with 5x and 15. Okay. Then we're going to get rid of my coefficients, so we divide by 5. Goes to 1, so x less than or equal to 3. Now, one of the lazy things that a lot of people do is they don't bring that sign with them every step. You have to do that. And then we graph. So we put our 3, because of the equal sign, we close our circle, point left, go left. Okay. All right, second example. Now, I'm not going to go step by step, but you should recognize that I have variable on both sides, so I have to get them together. Okay, and so what I want to do is, again, I want to move the smaller. Okay, so I want to get rid of the +5x, so I'm going to use a -5x on both sides. And again, remember to line up your x pieces. Those go to 0. 7 and a -5 leaves me a 2. At this point, we're at a 2-step situation again, so it shouldn't be too bad. Bring your signs with again. Okay. Divide by 2, goes to 1. Okay. Now again, if I get this situation, turn it around. Get your variable on the left side. Makes it easier for us to graph. Now, I always hear somebody say that, well, my teacher always wants me to put my variable on the left side. Okay. And like I just did, I can do that at the end and switch it. But this is why I don't like to go in and bring it to, or move the bigger one, because if I go here now and subtract my 7x, it becomes -2x. And again, it's not that we struggle with negatives so much, it's that, we lose those signs from time to time. And so when I go here, and then the piece you got to remember, hey, I'm dividing by -2. And since I'm dividing by -2, I got to switch my sign. Okay. All right, now that idea, though, I want to quickly go through is the check. Okay, so what I want to do is I want to check 3. I want to make sure when I plug it into my original, that 2 sides balance. So I have 5 times 3 plus 2. I want to know, is that going to be equal to 7 times 3 minus 4. So 15 plus 2 gives me 17. 21 minus 4 gives me 17. So 3 is that point that we want to compare to. It's either everything on one side or the other of it. Second point I want to check is 0. Okay, so in this case, 0 should work. Okay, 0 is the solution. We always go back to the original. And here's a nice reason for using 0. That would be gone. That would be gone. Because when I take 5 times 0, it's 0. 7 times 0, it's 0. And so now I can quickly and easily see that, hey, is 2 greater than negative 4? Yes. All right, so that takes care of the linear inequalities. Hopefully, if we are doing pretty well with our linear equations, the solving part won't get too bad for us. And then I'll come back and make a separate video for the compound situations.